These reactions, these questions, is something that we discussed already. You got carboxylic acid, we change the OH with the hydrogen. So how do you do these things? Well, we just talked about the different way. One, some of you think that, oh yeah, that's the aldehyde, so maybe I'll just use a liquid hydride, but you already know this is not what's going to happen. I mean, you get this, but these get reacted further, you get the primary alcohol. That's the issue. So what is the trick to play? You convert that to the reactive acid chloride by using thionyl chloride. Does the book describe the oxalic chloride for doing the job? Maybe we haven't talked about it. We'll discuss in chapter 20. Anyway, you will see another reagent later. But this one converts this OH to chlorine, and then acid chloride prepared. Then you can replace the chlorine with the hydrogen with a weak hydride. The choice is a very, very weak hydride. That's basically the tri-ketene hydride. So that provides a way to produce aldehyde for the carboxylic acid. But as I showed you already, this is not the only way to do it. The other way to do it is basically using the lithium hydride, make this all the way there. Then you're using basically PCC, PDC, choline, swan oxidation, all the things that we discussed, oxidize primary alcohol to the aldehyde, which is alcohol. So it's either you making an acid chloride using a weak hydride to do that, or reduce all the way down to the primary alcohol and then oxidize the bound oxygen to produce an aldehyde. So either way, you get the same product. So that is something that I talked about already. This conversion, you have a carboxylic acid, you replace OH with the nitrogen. You're producing ketone from the carboxylic acid. So this, what you should remember that is alkyl, as an alkyl chain is nucleophile. But if you think about the Grignard is not going to do it because Grignard is basically going to be killed right away by the acid. That's not going to work this way. So Grignard normally is going to be killed by the acidic proton, so you cannot use a Grignard at all. So another way is that you basically have to convert the acid chloride into the acid chloride, I mean, the carboxylic acid into the acid chloride. Then you got to use a mild nucleophile. Using a Grignard, for instance. Then Grignard makes an attack, pick his chlorine groups out, and you get this. But you know that that's not going to stay there. Another Grignard makes an attack, and then you get the tertiary alcohol. That's a problem with the Grignard with the acid chloride. Reaction doesn't stop with ketones. So what do you do? The reagent we just talked about that with cuprate. Cuprate is a milder nucleophile that makes a reaction with the chlorine once, and you make this, and the reaction stops right there. So that is something that we discussed today. So hopefully, it's giving an appeal. Here's another way, by the way. I mean, we can think of so many different ways to make the same thing happen. And so in case you don't remember that, there's still a way to do it. I just want to share that it's an alternative way. One other way is making that as an aldehyde. Carboxylic acid, we just talked about how to convert an aldehyde in the previous slide, right? Either we make an acid chloride reacting with a weak hydride, or completely reduce the primary alcohol to oxidize to an aldehyde. Either way, you can make a carboxylic acid into an aldehyde. Then what do? Then you do the reaction with the Grignard, right? Grignard makes an aldehyde reaction, you get an alcohol. Then all you need to do is just oxidizing the secondary alcohol into the ketone. So this is a simple thing to do. You can use a PCC for doing that. You can use a chromic acid. Whatever the way, this can happen. So if you must use a Grignard, there's still a way there. So I'm just showing you that there's not just one correct answer. There could be multiple right answers. We have a ketone here, right? So we have to sample ketone somewhere. But it looks like this is not something that we cannot use easily. So we got to think about doing some way to make it happen. But this 5-member ring can give an idea that this is the same 5-member ring. this carbon that bearing oxygen is that carbon. So that is basically what we need to oxidize first. So think about that. If you having a acid chloride there, then you can easily produce that one by using the diethyl cuprate, right? But this is kind of the wrong way to explain it. No green, because if you get a greener, you get a tertiary alcohol. So that you're gonna make this. So you're gonna have a diethyl cuprate for doing that. Then how you gonna make this one to that? Right? That's basically something we talked about. That's coming from the carboxylic acid. This carboxylic acid reacting with that diethyl chloride, make an acid chloride. This is basically oxidizing from this primary output of the carboxylic acid. So all the reactions that we talked about before, you're going to need to make it out. Is there another way? Can you think of another way? Well, there's always another way. First of all, we oxidizing the aldehyde, right? Then you can use a grignard to make the reaction with an aldehyde. That's OChem1 chemistry. Then you get the alcohol. Then you can oxidize it to a ketone. So there's always another way. So you just forgot about the diethyl cuprate getting to the acid chloride. Then still there's another way to make it out. This has to be really creative. How are you gonna make that? You can clearly notice that this 6-member ring must be that one. So that means that this carbon is this carbon. But we don't have any oxygen there, nothing. Then what do you need to do? We're gonna add an oxygen here, right? Make an alcohol there. So we're gonna do the hydration reaction. What we really need to do that? Oxymotilation, chemotherapy, or the hydrogenation. I'm just trying to remind you the things that you need to do. This is a hydrogenation because you're going to make an anti-molecular addition of the water. So this makes the OH goes less oxygen to the side, right? So that's an anti-molecular product. That is a bit of OH, and then it's oxidative walk to make it happen. Then you can oxidize to make a carboxylic acid. Then you can make an acid chloride. Then all you need to do is this part as a diethyl cuprate. So that's the reason why you need all the reaction at the fingertips, not just the blue part, the whole part as well. Oh, one more question. That time is up.